Hello everybody and welcome to today's video where I'm going to be showing you how we can create a drag to select multiple units inside Unity's entity component system. So of course with Unity ECS, which is part of their data-oriented technology stack, or DOTS, often we're going to be making games that have lots and lots of entities, specifically things like real-time strategy games or maybe city builder type games. Now oftentimes we're going to be having to select units to direct them to what they want to do. Of course, if we have lots and lots of units, it would get quite annoying to select every single unit individually, like holding down the shift key or something like that. So that's why we're going to be creating an area selection system where we can basically, drag out a rectangle on the screen, and then we'll select all entities that fit inside that rectangle that we see on the screen. So this video is a continuation video of my single unit selection system where I showed you basically how we can, just click on a single unit to select it or deselect it. And we can also hold down the shift key to select multiple units. Now, you don't necessarily need to see that video before watching this one. I've basically designed these two systems so they can work side by side, or we can just use one or the other if we want to. However, I still would recommend watching that video for a little bit of extra context on what we're making here. Now, before we get into it, I will just warn you that this video is going to be a little bit more complex than the previous video. The last one, we're basically just doing a simple raycast. This one's going to be a little bit more complex, and we're going to be utilizing more features of the DOTS physics package. I don't think it'll be that difficult if you just follow along, but some of the things might get a little bit confusing. So of course, if you do have any questions for me, feel free to leave those down in the comment section below, or you can ask me over on Discord over at tmg.dev/discord. By the way, while I'm at it, if you do enjoy today's video, I'd really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots more videos about Unity's entity component system and their data-oriented technology stack. And of course, let me know if there's anything else that you would like to see me create in Unity DOTS. So anyways, let's start off this video by talking about, what's kind of the basic idea of what we're going to be accomplishing here. So what's going to happen is we're going to detect when the mouse button is being held down, and then when the player actually starts dragging it. So basically once the current mouse position is past a certain distance that we've kind of predefined, that will basically activate the dragging state, so we can kind of confirm that the player is now dragging the mouse. Once that happens, we're actually going to be drawing a selection area onto the screen just by using just a simple MonoBehaviour on GUI function. I did actually find this from another tutorial video on YouTube from a channel called The Screaming Fedora. He made a pretty good selection system in just regular Unity on this, and so I'm using just that kind of like visual representation of the area selection. So I will leave a link to that video so you can reference that. Also go check out his channel. He does some other things with Unity ECS as well, so he's got some good stuff on there. So anyways, once we have the selection area basically drawn onto the screen, and the player has determined that this is the selection area that they want, to actually go ahead and lift the mouse button, and then what we're going to do is we want to select all units that were inside that area. So the way we're actually going to do this is we're actually going to project rays from the camera out into the world on basically those four corners of that selection area that we've created, and we're going to create a mesh from those four corners in the world and the camera position to create a rectangular pyramid that will serve as our selection area. So that means that everything inside and intersecting with this mesh will raise a trigger event. Because of the pyramid shape, this would theoretically allow us to select units that are flying above the ground as well. Now this mesh is going to have a physics shape component associated with it, and we're going to set it to raise trigger events. So that basically means that when certain objects on a specific layer collide with this particular object, that's basically going to raise a trigger event, and then we can select all those objects that have that trigger event happen. Now there's a couple kind of interesting things that comes to this. So basically we need to make sure that this object actually lives in our world for one full physics step, just so the triggers can get properly detected. If we destroy our shape that we've created too early, then we actually don't get the physics detections happening. So that kind of gets into a little bit of the complexity and some of the quirks of the Unity DOTS physics system as it stands right now. So anyways, once those trigger events are raised, we'll basically just go through all the trigger events and just kind of, confirm that we can actually select this unit because it has a selectable unit tag. And if it is, then we'll just go ahead and add the selected unit tag onto it. I talked about this in my previous video, but basically what happens when we add the selected unit tag to an entity, using system state components, we're actually going to spawn a selection ring into the world so that we can actually get a visual representation of the entity that is selected. So with all that being said, let's go ahead and jump into Unity and take a look a little bit at the setup here. So a couple things that differ from last time, we now have this selection manager. Now this is a MonoBehaviour, just called selection manager. This is actually important because this is what we're going to be using to actually draw the GUI rectangle onto the screen, because that depends on the onGUI function, which is only available on MonoBehaviors. And so I'll be showing you how we can basically look at our system and determine, when we're in the dragging state and, when we can show and hide that UI. Also, if we're to look at these selectable entities, just a couple things to point out. Of course, these have these selectable unit tags, so we can select them. They also have a dynamic physics body. This is really important because we are using Unity Dots physics triggers. If we do not have this physics body component on them, then the trigger events will actually not be raised. So we can just basically set it to a dynamic body, and we don't need to set anything else other than the defaults. Other than that, we also do just have the physics shape, which we had in the tutorial last time. Of course, this is a shape type of capsule. For collision response, that's set fine to collide for now, which is just the default. And then for collision filter, you'll remember that I have it set to the units layer and it collides with everything. Just remember, if you don't have these set up, which you won't by default, you can just, click on here and then go to edit physics category names, and you can add as many layers as you want, well, up to 32, I guess. And then the last thing that I want to point out, which again, I did talk about in the previous video, is this selection ring here. You'll see that this is basically just kind of like a large box shaped thing. And we have a custom shader made with shader graph on here. So we can basically project this ring onto any mesh that it intersects with. So as you see, if we move it up or too far down, then that mesh is no longer being displayed. Now, again, I did not come up with this shader myself. I did follow another tutorial online, which I will link in the description below, because I do think it is a good and helpful tutorial. But if you do download the project files associated with this video, I will of course include all that stuff in here. And one thing to note, because that is using shader graph, this project is using Unity URP, the Universal Render Pipeline, and I also have upgraded the project to Hybrid Renderer V2. All right, so real quickly before we actually get into creating new code, I'm going to show off the selection manager. Now this is the script that I created in mostly following along with that tutorial from the Screaming Fedora, where again, he basically showed how to create this kind of selection area. Again, he was just making it in regular Unity programming. We of course integrate this into Unity ECS. So a couple things that I did differently is you'll see a reference to our unit selection system. This is the system that we began creating in the previous video for single unit selection, and we're going to be expanding off that script in this video. You'll see that, when we start here, we'll actually need to get a reference to that system. So we can just do a world.defaultGameObject injection world.get or create system. So this is actually just going to get a reference to that system that's running. Of course, because we're not putting it in any crazy world, we can just get it from the, just the default game object injection world, which is basically just the default world. You'll see in the onGUI function, we're actually going to look at the unit selection system and see if we are dragging just by looking at this is dragging property. And then we're actually just going to call this get screen rect. You'll see this also depends on something from the unit selection system, which is the mouse start position. And so based off of that, as well as the current mouse position, we can actually draw a screen rectangle as well as a border. And so these are just kind of the helper functions here. Of course, again, I will leave a link to the tutorial that I followed, and this will be included with the project files as well as the code associated with this video, which you can access in the links in the description below. All right, so we'll go over to our unit selection system, and we're going to, of course, start by defining a few variables here. So the first one we're going to define is actually a private entity archetype. And this is going to be basically our selection archetype. It's good for us to just, have a nice reference to this so we can easily instantiate these in our world once we get to that point. This is basically going to be the archetype of this kind of mesh that we're spawning into our world to detect trigger events. Next, we're going to need a private float3, and this is going to reference the mouse start position. And then finally, we'll just need a private bool to determine if the player is dragging the mouse. So of course, we'll just create two public properties for the mouse start position as well as the is dragging Boolean. So we can reference these from our selection manager. So you'll see if we go back here and now it is no longer yelling us about those two values. So in the on create, the only thing that we're actually going to need to do additionally here is set up our selection archetype. So we can just do an entity manager dot create archetype. We're going to need a physics collider so it can actually detect those trigger events. It will need a local to world so it can actually live physically somewhere in our world. And then finally, I just have this custom tag called the selection collider tag. So we can basically, look for any of these entities that are tagged with this selection collider tag. So now moving on to the on update function. So in here, the first thing that we're going to want to check is when the player starts holding the mouse button down, we're just going to get a reference to that mouse position and we'll set that equal to the start mouse position. So pretty basic stuff. We'll just do an if input.get mouse button down for mouse 0, which is the left mouse button. We'll set mouse start position equal to input.mouse position, just the current mouse position. Now, the next thing that we need to do is detect when the player is actually dragging the mouse. So here first we'll say if input.get mouse button, again passing in 0 for the left mouse button, and we're not already dragging the mouse, because if we're dragging the mouse, we don't need to detect if it needs to be dragging the mouse again. So here what we're doing is a check to see if the distance between the mouse starting position and the mouse current position is greater than a value that we've defined. In this case, I've just done 25 pixels. We'll go ahead and set is dragging equal to true. So now if we come over to Unity and enter play mode, we can click to hold down the mouse. You'll see if we just move it slightly, we don't get the selection GUI showed up yet. But if we go just a little bit further, you see that now once we've moved past 25 pixels, we do see that selection GUI show up. And we can kind of continue dragging this selection area out as large as we want to. Now, however, when we unclick, the selection area basically still is displaying. We don't, set the is dragging to false anywhere yet. And of course, we're not, doing any logic to select the entities yet. So now we'll come back to our unit selection system, and here's where we'll actually add in some logic to select multiple units. So we'll go to the existing code that we have where we say input.get mouse button up, passing in 0. So this is basically when the player releases the left mouse button. So the first thing that we'll do is to check to see if the left shift key is not held down. If it is not held down, we'll deselect units. Otherwise, we'll just continue adding to the selection. In this case, that is fine to leave it as is because, say if we have a couple units selected and we're holding down shift, maybe we want to drag to select more units. Now, where things get a little bit different is where we want to determine whether we should select a single unit or do our multiple unit selection. So the way we determine that is we basically just say, if we are dragging the mouse, then we'll select multiple units. Else we'll just proceed with selecting our single unit. So of course, we'll just go ahead and implement the select multiple units method here. The first thing that we'll do is we'll just reset is dragging back to false so we can actually stop displaying that graphics onto the screen. So after that, the next thing that we're going to do is get reference to the top left as well as bottom right corners of this kind of selection area that we dragged out onto the screen just by doing a math.min and a math.max between the start mouse position as well as the current mouse position. Again, this is going to be the current mouse position when the player releases the mouse button. And then using those values, we can actually create a rect just by doing a rect.minmaxrect and just passing in these 4 corners that we calculated here. So now with this rect, this is basically going to give us access to the 4 corners that we dragged out here. And what we're actually going to do is we're going to create a ray from the camera to each of these corners. So we'll just create this array called corner rays, and we'll set this equal to a new Unity engine.ray array. This is important that we're using the Unity engine ray because we're going to be again using our main camera, and we can do a screen point to ray passing in each of our corners. So the first one will be rect.min, the next is rect.max, and then the final 2 we're actually going to be creating new vector 2s just by using the minimum x and the maximum y, and then the maximum x and the minimum y. So again, this screen point to ray function, which is the same one that we used down in the select single unit here, this is going to return us a regular Unity engine.ray. So we just need to make sure that we're using that. Although writer tells me that we don't even need that. So we can just, define it that way and make it a little bit cleaner. So again, what this gives us is it basically gives us 4 rays from the camera position going out to the 4 corners of that selection area and continuing out into the world. The next thing we're going to do is get the 5 vertices of our selection area. The first 4 will be from the rays and the 5th will be the camera's position. So we'll define a native array of float 3s called vertices. It will have a length of 5 and a temporary allocation, as it will just be disposed at the end of the frame. Using a for loop, we'll populate the first 4 elements of the native array by getting a point 50 units out from the camera on each ray. This number is something you'll have to set specific to your game, but in this case, a value of 50 is more than enough for our selection area. Then after our for loop, we'll set the 5th element of the ray at index 4 to the position of the camera. Okay, so now we have our 5 vertices. Now we need to actually create a collider. But before we do that, there are a couple things that we need to set up. The first one being a collision filter. So again, we did this in the previous video, and this is basically where we specify which collision layer this particular object belongs to and which one it can collide with. So here's the collision filter that I've created. You'll see that it belongs to the selection layer and it collides with units. We only want this one to collide with units because we only really care about colliding with units. We don't care about raising trigger events with the ground or anything like that because we know that we're only going to be selecting things on the units layer. Now, if you didn't see the previous video, I can just show you this off real quick. Basically, I just have this flags enum called collision layers. And then I've set these up so they basically match these collision layers that I've defined in Unity over here. Then before we actually create our mesh collider, the last thing that we need to do is create a physics material. So we can just do var physics material equals a new unity.physicsmaterial.default. So that's just going to set it up with basically the default properties. However, we do just need to change one thing on our physics material. So we'll actually set the collision response equal to a collision response policy of raise trigger events. So this is basically going to mean that our mesh is going to be considered a trigger and not a actual solid collider in our world. And again, this is what we want because we want to basically detect an intersection between this and our units by using triggers, and we don't need this to actually physically affect the units in our game. So here's where we're actually create our collider. So we'll just call this the selection collider, and this is going to be a convex collider. And you see that there's this nice handy create function here. Notice that this actually returns a blob asset reference of collider. So inside the create here, we can just pass in our vertices. Again, that's our native array of float 3s. Next, it's going to need some convex hole generation parameters, and we can just set these as the default ones because we don't need to do anything special. Then it's going to need our collision filter, and then finally our physics material. So once we have all those things, that basically generates this convex collider for us. Now I'll actually need to instantiate our entity into the world and then assign it that convex collider. So say create a new selection entity. We can just do an entity manager.create entity, and here we can pass in our selection archetype. Again, this is that archetype that we created kind of back to the beginning here, where it just has the physics collider local to world and the selection collider tag. So that actually spawns it into the world. And then the last thing that we actually need to do is the entity manager set component data. We're going to, of course, be setting this on the new selection entity. And here we can pass in a new physics collider, setting our value equal to that selection collider that we just created right here. Okay, so now we will come back to Unity. One other thing to point out is I do have this physics debugger entity here. It just has this physics debug display and it's being converted to an entity. And we just have enabled the draw colliders as well as draw collider edges. So that means when we press the play button, we can actually just drag a kind of selection somewhere randomly in our world. And you'll see that this is the actual mesh that we're creating. So we can kind of do that to, confirm that our mesh is being generated into the world. And we do have this basically nice shape that exactly mirrors the selection area that we have selected in our world. However, it gets a little bit weird because we can, just keep, spawning these into our world because we're not actually, destroying them or doing anything with the trigger events on there. So that's what we'll be fixing next. So coming back to the code, we're actually done with the unit selection system. So now we'll open up this new class here, which is the select multiple units job system. It's still a system base, but this is where we actually are going to be scheduling our selection job, which is what actually detects the triggers. And then that's where we can actually select our entity. Now, I did make another video previously that goes a little bit more into depth on these trigger events, but I'll just give you a quick rundown of it. Basically, we use these component data from entities, looking at this selection collider tag. Now, the component data from entity, also made another video on these, but this gives us reference to everything with this data type in the game world. In this one, we're looking for the collider tag. This is basically going to be any of those selection volumes that we're creating. And then also anything with the selectable unit tag, basically any unit that can be selected is going to be into this collection here called units. And then we also just need an entity command buffer called ECB. So you'll see with this iTrigger events job, we need to implement the execute function, which does take in a trigger event. Here we can just get references to the two entities involved in the trigger event, which are just called entity A and entity B. And then here we just do some logic to determine which entity is essentially the selection volume and which entity is the unit volume. So basically, once we've determined that at the end, we have the selected unit here, basically just equal to either entity B or entity A, depending on which one it is. And then we can just do an ECB.add component selected entity tag on that selected unit. Again, this goes back to the previous video where once we have that selected entity tag, then using system state components, we'll basically spawn that UI selection ring. And then once this selected entity tag is removed from that entity, then we'll actually just go ahead and destroy that UI. So with that being said, this is where things start to get a little bit more complex. But again, if you just follow along, I don't think it'll be all too difficult. So the first thing that we need to do is we want to run this system in a special group. So this is going to be updating in the group type of fixed step simulation system group. Now we need this running in the fixed step because that's basically where these trigger events are taking place. So this system needs to run in the fixed step simulation system group, which does of course run on a fixed time step. Okay, now for this system, we only want it to run when one of these selection colliders is present in our world. So we can just say require singleton for update, passing in the selection controller tag type. So that basically means that whenever we have one of these in our world, this system is going to run. Now, once we have that set, we just need to define a couple variables that our iTrigger event job depends on. So we need a reference to the step physics world, the build physics world, as well as the end fixed step simulation entity command buffer system. We're making sure we're using the end fixed step simulation one. And then we can just get references to each of those systems, but just by doing a world.get or create system, passing in the type of system that we're looking for. All right, so now in the onUpdate function, we can just go ahead and get reference to our entity command buffer just by taking the entity command buffer system and doing a .create command buffer. Feel free to check out the video that I did on entity command buffers to learn more about that. And now here, we'll actually go ahead and schedule our selection job. So we'll do a var job handle because this is going to return a job handle. Set this equal to a new selection job. And here we'll just need to set these public properties on here. So we'll say selection volumes is equal to get component data from entity, everything with a selection collider tag. Units is going to be a get component data from entity with a selectable unit tag. And then finally, ECB is equal to our ECB, just so we can pass in our entity command buffer there. Now you'll see that we have a red line after this. So we'll actually just need to go ahead and schedule this job. And here's where we pass in our step physics world dot simulation. And then we're going to need a ref to the build physics world dot physics world. And then finally just to pass in the dependency of the system here. So that will basically schedule the job. Now we do need to do some follow-on things after that. So because we need to depend on the job completing, we'll just do a job handle dot complete. So this ensures completion of the job before we can proceed here. So of course we can just get our selection entity by doing a get singleton entity selection collider tag. Now the reason that we're using singletons, I should have mentioned this a little bit earlier, is because there's no possible way that in our game that a human is going to be fast enough to actually create multiple of these selection colliders inside the time of one physics time step. So we can pretty much guarantee that we're only going to be having one of these selection entities in our world at a time. Now, if these are not being properly destroyed, of course, we're going to get all sorts of errors, and that's something that we need to figure out. But for this sample project, it's fine that we can actually use this get singleton entity. So now, like I mentioned at the beginning of the video, we basically need to put in a 1 frame delay from when this entity lives in our world and when we can actually destroy it. And that's so we can actually get these proper trigger events to happen in our game. So I've created this steps to live data component. It just has a public integer value. And basically what's going to happen is, every frame that this is active, it's just going to decrement that counter by 1 so we can properly clean it up. So the first thing that we're going to do is get the steps to live data component off that selection entity. And then we'll just go ahead and decrement that value by 1, and then make sure that we actually set this back to the entity so those changes are reflected in the next physics step. Now note that I call this steps to live and not frames to live, because again, this system is updating on the fixed time step rather than a perfect frame by frame basis. So then what we can do is we can do a check to see if the steps to live value is less than or equal to 0. If so, we can just do an entity command buffer dot destroy entity. Now, however, one thing that you may have noticed is we're not actually ever assigning this steps to live data component to that selection entity. So that's what we'll do right now. So we'll do an else after the if has component. So this basically means if that selection entity does not have the steps to live data component, we'll just go ahead and add the data component, and then we'll go ahead and set the value on that to a value of 1, just because again, we only need this to live for 1 frame. So again, when we schedule that job, it's going to run this execute function, which is basically just going to determine, when there is a trigger event, which one is the selected unit, the unit that we need to select, and we'll just go ahead and add that selected unit tag to it. All right, so we will come back to Unity, and you'll see that now when we go ahead and actually drag a selection area, we can basically select a subset of these entities that are inside this kind of selection area. Of course, we can kind of, make different new selections, and it's going to deselect all the previously selected entities and select just the ones that we want. Of course, we can just, do an area selection on one single entity if we want. And of course, we can still do the thing where we hold down shift and basically add to that selection. So now we kind of, grow the selection just by holding shift like that. Of course, we still have the functionality where we can click off and just select single units just like this, like we did in the previous video. And then, everything basically just, continues to work as exactly as you'd expect it to. Anyways, that's going to do it for today's video, basically showing you how you can make an area selection using Unity's entity component system. I know this one was a little bit more complex than the previous one. Hopefully you're able to kind of follow along with most of the steps. Again, you don't really need to necessarily understand how everything 100% works to kind of follow along with this. But if you do want to learn a little bit more, you can reference some of the videos that I mentioned throughout this video. Of course, if you do have any questions or need any clarification on anything, or even want to suggest some future videos that you'd like to see me make some tutorial videos on, feel free to let me know down in the comment section below, or of course over on our Discord over at tmg.dev/discord. So anyways, once again, if you did enjoy today's video, I would really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots more videos about Unity's entity component system and the data-oriented technology stack. And with that, I hope you all have a fantastic rest of your day, and I will see you in the next one.